Alrighty, hello, and welcome to another tutorial. Today's tutorial is going to be on SQL. Now, you may notice that there's already a tutorial on SQL already uploaded to my channel and in the playlist. The issue is that tutorial is old. We're going to be looking at a new tutorial which is more applicable to the contents of your testing. That being said, the contents of the old tutorial is still also very important. And if you find yourself struggling, well, you should probably look at that too. This tutorial is going to be on how to open, read, edit, and close a database. The already existing SQL tutorial is purely on queries and not how Python does it. I recommend you go to the actual query video and watch that so you learn how to write a good select query. And in this video, you guys are going to learn how to open and read a database properly. And if I have time, I'll show you how to also insert or update, but you guys won't be using that. So, I've presented a simple question, a question in which is basically the output, or like it's the format for what we normally put in an exam. This is something you would be expected to do. In this question, you're going to write a function called SQL to JSON, which, given a database name, so it's a file path, a table name, in which is the actual table within the database that you're reading from, and optionally a JSON name, which will be our output, as seen here. And then is going to take the data stored in the database and store it in JSON format. Here is what a table looks like. Notice you cannot open a .db file. This is on purpose. You're not supposed to be able to open those. You need a specialized reader for it. So you're going to have to trust this table. So our table consists of an ID integer, a name text field, a description text field, a hotkey text field, an XP amount integer, a base cost integer, and a category text field. Which means when you convert this from SQL into its Python counterpart, it's all going to be int and string. Lovely. You don't need to know anything about Bloons tower defense, but I gave a little spiel because that's what I based this table off of. JSON will be formatted as follows. The structure is a dictionary of dictionaries. See the output. It is a dictionary, and each element of the dictionary is a key bound to another dictionary. The key is the ID number converted to a string. The values are a dictionary containing all information except the ID number. Simple. Yeah, for more information resulting on the JSON, take a look at the JSON. So, let's go ahead and code this. First things first, def SQL to JSON takes in the database, in which is a string, the table, which is a string, and optionally a JSON file string, which by default is set to towerinfo.json. The output is nothing. There is no output. So if you guys don't know what this is type hinting. It allows you to see how I hover over it. Now it says string. It's because I am type hinting each of these variables. So I know this function takes in 3 strings, outputs nothing. Next, we're going to open the database. Opening the database is not very hard, for you see, databases are essentially files. They have their own import SQLite3, exactly how you would say import CSV or import JSON. So if you wanted to work with a JSON file, you would import JSON. If you wanted to work with CSV, you would import CSV. It's the exact same thing. You want to work with databases, import SQLite3. In this question, I'm actually going to need SQLite3 and JSON. Now, files and databases, as I continuously say, are very much the exact same instance. For a file question, it's open the file, read the data, mutate or work on said data, optional, write, return. If you're ever coding a file function, this is always the layout of what you're going to be doing. Open, read, work, write, return. Databases are exact same. Open the database. Read the table. Work on said table. Optional, write, database or file, only file in 1MD3. We will never have you write to a database. Return, optional. So, this entire comment section is essentially our function. So, let's open the database. How do we open the database? Well, first, as opposed to a file, where a file is simply file handler equals file.open, well, regretfully, SQLite's not as clean. A database comes in two separate parts. A connection, in which is SQLite3 dot connect to the database. So we have to establish a connection to our database. This is the exact same as if you guys were working on file.io and you did file handler equals open file read. Right? It's the exact same general premise, except it's a different library. Once we have a connection, we then need to establish a cursor. Cursor equals connection dot cursor. Now, a cursor kind of acts as like your mouse cursor. When you click on something in a file, it tells you where you are in said file. In a database, your cursor is going to be navigating through the database file, selecting information. So our cursor is very important to have. When we want to close the database, then we can say cursor dot close connection dot close. It is very important that you do this. Now, you guys are used to being able, with files, to say with open file read as fh, and then auto close. SQL doesn't have that type of thing, but it has something similar. Now, I don't remember how to do it, so I'm going to have to look up Python SQLite3 closing. Whoops. Closing library. You will be given this in your exam, by the way. Maybe it's with syntax that I want to Google. Nope. Here we go. So, from context lib, you can import something called closing. Closing is an automatic function where if something you're creating has a close method, closing will automatically close it. So I'm going to copy this, and I'm just going to bring them straight in here. Notice how my VS Code has refactored all of the code. So instead of writing connection equals cursor equals, we can instead write with closing, then connect. So instead of aquarium.db, it's just going to be our database variable. Then we create our cursor, like so, and now inside this indent, we can code. Outside of this indent, connection doesn't exist. Connection is closed. So, next, we need to read the table. That was the next comment. So, I'm going to indent this inwards, and we're going to read the table. Read the table. Do-do-do. In order to read a table, you're going to have to execute a query. And in order to execute a query, you need to tell your cursor to execute said query. So we're going to call cursor.execute, and we need to pass it in the SQL query that we want it to run. So in this case, we need to do select all from table. Notice table's a variable. I've used a format string, which allows me to put table into the query. This means that this variable can change, and this query will change accordingly. After cursor has run the execute, we can now say data equals row for row in cursor dot fetch all. So now that we have a select all query inside the cursor ready to be executed, we're going to fetch everything that resulted from it. And if I print data, you will see that we will get, I gotta close this, and I'm gonna delete these because they're just taking up space. When I run this, you will see we get a list of tuples where each tuple contains information. Thing about tuples is they kind of suck, right? Like, no one likes working with tuples. We want to work with dictionaries because these are all named keys, right? This is ID, name, description, hotkey, XP, blah, blah, blah. Luckily, there is an easy way to convert something to dictionaries if you so want. And that's by saying connection.rowFactory equals SQLite3.row. What this will do is if I rerun it, you'll see we now have a series of row objects. Row objects you can't read, but row objects can be converted into dictionaries, which you can read. ID 0, name, boomerang, description, blah, 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 hotkey W, XP, blah, 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 base case, blah, 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 category, blah, blah, blah. This is much more human readable. I'm going to hoist data to the global scope, which now means that I can come out of these indents without any fear. So now I can work under this comment. Mutate or work on said data. Remember, we need an output format in which is a dictionary of dictionaries. For row in data, we are going to add an entry to this dictionary, right? So, output format at string row ID, and that's going to become another dictionary. Specifically, it's a dictionary with values that we already know. We have name, in which is row name. And I'm actually going to change these to be single quotes just because it's faster to type. Additionally, we're going to have description as row description. I'm actually going to copy and paste this because it's going to be faster. So description, Next is hotkey, hotkey, XP, XP, base cost, base cost, and category. So, if we now print output format instead of printing data, you can now notice it is a dictionary where each key is another nested dictionary. Lovely. That's exactly what we want. Next, we need to write the data to a JSON file. Well, you guys luckily already know how to do that. With open JSON file, write as insert variable, JSON.dump, and we're going to put output format. Closing the database has already been taken care of via our closing library, and we can return. If I make an output JSON as the output, run the function, we now have an error. Dump requires an additional argument. Haha. The file pointer. Output exceeds the size limit. Turns out I've forgotten how to write to a JSON file. Totally understandable. It's been a while since I've had to do it, so I'm going to Google Python write to JSON file. Y'all should probably be screaming at me right now that I'm such an idiot. It's dump data then file, not file then data. Dump data file. And no more errors. And if I check output.json, it's ugly. No one likes ugly, so if we take a look, I believe there's going to be an optional parameter called indent, where you can give it a tabbing. So now, if I rerun this and reopen this file, nope. Output, there we go. So now it's all indented. And if we compare the two files side by side, you can see they're exactly the same. Beautiful. But we have a small problem. This final line. If opening the database fails for any reason, attempt to open it again, but with .db appended to its name. If it fails a second time, raise a custom exception. Well, we know how to do custom exceptions, right? Class, database, error, exception, pass. But how do we open something and on failure open it again? Well, this is try except territory. We should try to open this database. In the event of failure, we should once again try to open this database. However, it's database plus .db. In the event of failure a second time, we then raise a database error. So, if on an exam you guys see, if opening something fails for any reason, try again, but with blah blah blah, you should instantly know that this is what you need to do. You should try, open, fail, do instruction. In this case, it's try open again. So, we then needed a second try block, and in the event that failed, we raised our custom error. Now, if the question says try opening it again, and if it errors, let it error, you would then only do this. Because if this errors, you don't want to catch it. You should let it error. But if you need to catch it to do something, then you do this. And that's the basics. That's the basics of opening a database, reading information, and working on it. Because it's exactly the same as file I/O. If you can do database, you can do file I/O. If you can do file I/O, you should be able to do database. Now, I did mention I'd show you guys how to do queries, specifically insert queries and stuff like that. Well, luckily, we can just Google that. Python database insert query, SQLite free. Like I said, it's outside of the scope of this course, but if you guys need to work on it, here is the syntax for an SQL insert statement. So this is what we want to run. And if we scroll down, connect to database, create cursor, execute insert statement, commit final changes. Commit is only run when something changes. And then close everything. And on this exact same page, I have create table, select data, where clause, like here's select data. Here's where clause. So boom. So, he inserts some things. Select data from employee where insert clause. It's exactly like your standard, your standard SQL. If you guys don't know how to do standard SQL, as in you need more help practicing with that, I once again invite you to go to my YouTube channel where I have all of these tutorials already uploaded. Go to Computer Science 1MD3. That's the final boss. We're not looking at the final boss, but we are looking at tutorial 11, Introduction to SQL. This is a 1-hour tutorial hosted online where I go over SQL queries. Dang. It's a little old, but it gets the job done. It uses SQL Zoo to host a database and gives you guys the ability to run some queries. All of your links right here. Just click and bada boom. There are a lot of queries here, a lot of things to learn. And I highly recommend you guys go through that video in your own time. This is a separate video because it covers things that weren't covered already. Anyway, guys, I'm going to leave it here, and I wish you guys good luck on the upcoming exam.